welcome to the lesson. We will be talking about the sine rule. We have three objectives: deriving the rule, calculating the sides using the rule, and finally calculating angles using the sine rule. Now, if you find this interesting, subscribe to this channel, your online librarian. Put a like and share with us your opinion on the comment section. So, the sine rule can be used with any triangle as long as we have been given enough information about the particular triangle. Consider triangle ABC. The angle at point A is corresponding to the side BC, labeled A. The angle at point B corresponds to the side AC, labeled B. And lastly, the angle at C corresponds to the side C, that is side AB, labeled C. Now that gives us the sine rule: A over sine A equal to B over sine B equal to C over sine C. Therefore, deriving the rule, we consider triangle ABC with their corresponding sides. Then we will draw the perpendicular height CP to meet AB at 90 degrees. We are just drawing. Consider a general triangle ABC. We'll find that sine B is equal to CP, that is the perpendicular height, over A. Because we are considering the angle at B, therefore, and we know very well that sine of theta is equal to the opposite over hypotenuse. That gives us sine of B equal to CP, the perpendicular height, over the hypotenuse A. And therefore, the height CP will be A sine of B. Also, sine A is equal to CP over B, the other hypotenuse. And that will get us CP, that is the height, to be B sine of A. And because this is a common height, the perpendicular height is a common height for this triangle ABC, it implies that A sine of B equal to B sine of A. We equate their lengths. And therefore, you solve that, you'll get B is equal to A over sine B, A sine B, over sine A equal to B. That will get us to our rule: A over sine A equal to B over sine of B. This can be extended to A over sine A equal to B over sine B equal to C over sine C, equivalent to sine A over A equal to sine B over B equal to sine C over C. Therefore, we can now work on some few examples to be able to drive the point home, the concept of the sine rule. We'll start with calculating sides using the sine rule. Find the length of A in this triangle ABC. As you can see, the triangle, we've been given two angles and one side, and so we want to find the other side. The angle at point A corresponds to the side labeled A, and the angle 34 degrees, that is at point C, corresponds to the side labeled, or the side AB, that is 10 meters. Now, match up corresponding sides and angles. You realize that depending on the information given, we have A over sine A that is the sine rule, is equal to B over sine B equal to C over sine C. But now you realize that the information is given on A and its corresponding angle, as well C and its corresponding angle. No information is given on B and the corresponding angle. So we equate those given. A over sine 41 equal to 10 over sine 34. You arrange and solve for A. We'll get that the value of A, that is the side BC, will be 11.74 meters. Let's do our second example for better understanding of this concept. Find the length of D in this triangle. Consider triangle CDE. We have been given two angles, one side, and you are required to find the value or the length of the other length, that is D. Matching up corresponding sides and angles as dictated by the sine rule. You look at the triangle, you realize that C over sine of C, the information there is given, as well D over sine of D, information there is given. No information given on E and its corresponding angle. This implies that D over sine 133 degrees equal to 10 over sine 37. Therefore, rearranging and solving for D will get us the value of D being 12.14 meters. Just a short break. Keep watching. We'll be continuing with calculating angles using the sine rule. just a short break. Keep watching. We'll be continuing with calculating angles using the sine rule. Now, calculating angles using the sine rule. You remember before the break, just in our previous lesson in this video, we were calculating sides using the sine rule. Now in this case, our example number 1, find the angle A raised to 8 degrees given the triangle ABC. And so because of that, we are going to find the angle at point A using the sine rule. And now, of course, we match up corresponding sides and angles. So, substituting into the formula, we only substitute depending on the information provided. So, as you can see, we have been given the side corresponding to the angle at A. Another information given is on the side C, corresponding to the angle at C. And therefore, no any information given on B and its corresponding angle. Therefore, 45 over sine of 8 degrees is equal to 38 over sine 23 degrees. We rearrange and solve for sine of A. We'll get sine of A is equal to 45 sine of 23 degrees over 38. So you simplify that to get 0.463. But we are supposed to find A degrees. So we are going to get the sine inverse of 0.463. And that will get us 27.6 degrees. Now, example 2, find the angle x degrees from the triangle XYZ. The side corresponding to angle at x is 38 meter. The side corresponding to the angle at y, that is 143 degrees, is 75 meter. Now any information given on the angle at z and its side. So we substitute into the formula, that is the sine rule, and we'll be able to say that x over sine of x is equal to y over sine of y is equal to z over sine of z. You realize that because we are lacking information relating to z, we only equate those depending on the information given. Therefore, we'll have 38 over sine of x degrees equal to 75 over sine 143 degrees. Rearranging and solving for sine x degrees will get us 38 sine 143 degrees over 75. You get that from the calculator, you get 0.305. And because we are still supposed to find x degrees, so we get the sine inverse of our answer. Therefore, x degrees is equal to 17.8 degrees. Now, what goes into the box? This is the assignment zone. It's good to take the assignment just to test whether you've understood or not. Remember to follow with our previous tutorials to be able to get more information. Calculate the angle, the unknown angle in the following. The triangle is given there with the information. So if you do that, you're supposed to get A to be 37.2 degrees. The other one will get you the value of B degrees to be 16. And another one, find the unknown side in each of the triangles below. If you do part A, you'll find to be 6.7 centimeter. And part B, it will be 21.8 millimeter.